Hey, I'm Dave, and I love making combat robots, but I'm not doing combat robots today. I am volunteering at Robot Ruckus. That's a part of Maker Faire Orlando that happens every November. I'm looking really forward to it. I'm going to get to see a lot of matches today. While I'm there, I'm hoping to talk to some builders and hopefully bring you guys some interesting views on what's been going on with combat robots at the insect level, mostly 1 and 3 pounders. Robot Ruckus is part of the Maker Faire Orlando event that happens every year at the Florida Fairgrounds in Orlando, Florida.
Oh, nice pop there time from Nibbler. And now Fallout trying to push Nibbler into the pit. He's done it.
All right, I'm here with Brandon. We're going to talk a little bit about his bot, Caddy Wampus.
Great and powerful Caddy Wampus, indeed. My name's Brandon Young, and builder of Caddy Wampus.
And do you have a team name? What's your team?
Sure. So my team's Bone Letter Robotics.
Okay, perfect.
Yes, indeed.
Great. So I saw this bot compete the first round.
Yes.
And I just had to come and take a look at it because it has this interesting little intent where you are doing an eccentric motor type action.
Exactly.
Can you tell me a little bit about what you're trying to do?
That's right. So Caddy Wampus is a unique robot because it's designed as a self-wronging machine, as I like to call it. So with most machines, when you come up into it, it sort of controls you in the area, right? But once you're there and you have them, you can't really do a ton with it, right? And so once you get the robot sort of in the center area, you're thinking, what else can I do with it? So like with Caddy Wampus, I generally have a claw on top of it. It's supposed to hold the other machine down there. But the key is this tail in the back. The tail, really the key effort here, is as it rotates, it's uninhibited by anything else in the machine. So as it rotates, it's full range of motion. So it's able to do multiple things. So first of all, the death roll idea. Someone comes in here, grab them with the head. As it tilts the robot over, it can invert them both. And as it inverts them both, this is protected. It's all the way back here. And the other machine can't do that either. So now they're within the robot's control until I release it.
Yeah, okay, interesting. So the intent is using this eccentric motion to kind of flip your opponent. Now,
exactly.
Now, normally you ran with the claws, but you didn't run with the claws this last go around.
Yes.
So were you having some issues with the servo or the mechanism?
So really, I fought a very, very scary vertical spinner that had just enough range, where as the claw normally sits here with its face sort of in the range there, he would roughly cut straight through into the jaw and rip it all off.
So you took that off intentionally because it wasn't a good matchup for the claw.
Terrible matchup for the claw. I only have a single servo. The first one got broken, so I need to keep it.
Yeah, right. Yeah. All right, very cool.
Yep, a little tricky.
And so that's a direct drive on the servo.
Yes.
And tell me a little bit about the innards. What kind of motors are you running?
Yeah, so this has the Repeat Max drivetrain for both of the wheels, direct drive as well, and then also the first generation Repeat Ultra for the lifting arm.
Okay.
So the way I like to describe it is it's a overkill. If I wanted to do a normal lifter, one that is more sort of in line with the robot's motion, I would use like a servo, like the head. But I wanted an overpowered drive system, so basically a 12-pound drive, you could say, to guarantee that when it throws, it has more than enough power to hit both the other machine and itself over, but also to reach high RPM in the quick moment.
Yeah, it had very high. You need that for the quick action.
Exactly. It's a balance of speed and torque. So it's a 1401 with a 2836, I believe, 1450 kV motor on it, on 3S LiPo. So it's enough torque where even though this were on like a wheel, it'd only be a little bit faster than the normal drivetrain is on a very eccentric tail like this, with like maybe 4 or 5 inches of reach on it, very fast. And the cam shape is sort of more rounded off, so you can sort of see there. Much more like a squirrel's tail, really. The idea is
like a cam action. You want to get slow, and then you want to really
exactly. I want it to get to the ground fast, but I want it to accelerate consistently as it goes through its motion. And if I gun it, it happens super fast.
Yeah, I saw that, and that's what got me really interested.
Yeah.
So, tell me, how long have you been running this bot?
So Caddy Wampus as an idea has been around for, I believe, 3 years, maybe two years directly. It's only run in full combat 3-pounders for maybe a year. A little change of that. It's been a sportsman before that point. The intention was, it was kind of like, okay, so I know the tail may get hit in combat, which obviously the scars show on it, or will it have enough power to throw the other machine? And so I really took a great bit of time to test that out in 3 pound sports and battles locally to myself at Macro in Maryland. And that worked pretty well. It was able to throw us up like a foot in the air. And the other machine, you know, several, like, I guess, feet across the machine, across the arena as it throws itself over. And so then I began honing the rest of the machine. It's like now it has this titanium armor on the sides of it, steel forks and inserts, titanium tongue in the center there for helping the tipping part of it. Now it's armored. Now the tail's a bit stronger as well. So I thought, okay, into the full combat it goes.
Okay. All right. So is this competition the first time it's been in full combat?
Is the 3rd time in its life now.
Okay. All right.
It went to the June G-School of... Oh. That it has. Plenty of scars on it, definitely on the forks there. It went to New Jersey back in June and did fairly well, like 3-2, I think. It went to Norwalk 2 weeks ago, actually, in October.
Oh, okay. All right.
It went 0-2 there because it hit the tail. And then now it's currently 0-1 on the day for the event. But still works, so on the next one, really.
Excellent. What do you consider the most challenging part of the design of this bot?
Yes.
And let's say ongoing development challenge?
So the big issue really is actually priming the tail. Because you don't think about it very much with the servo. It's sort of just automatically resets. With the servo, with the tail,
wherever it wants to.
Exactly, wherever I left it. So I have to keep resetting the tail every time it moves somewhere. So now, let's say I fight a robot, it throws itself up the air, but it lands sort of like this, right? The tail is slightly holding the wheels off the ground, so it doesn't have a lot of friction like there. And so as a result, that creates now, it looks stuck. And I'm like, oh, I need to fix that. And I have to keep aware of the other opponent coming around it. Also have to reposition the tail a little bit to make sure it's free again. And then, most subtly, I have to prime it the right direction for whenever it next flips.
Do you usually go in the same direction, or do you flip during a fight?
I would like to say I'm smart enough to know which way, but no.
You're just mashing sticks?
I'm just mashing sticks. I just know that if I throw the tail, something will happen. I will, at the beginning of the match, know. At the beginning of the match, I'm like, okay, it's like this way, I'll go the opposite direction and throw it that way. But after it gets 1 or 2 flips in, it's like, okay, mash, get it going, do something on it. And so that resetting has a lot of time and brain RAM that goes into that, which wastes a lot of time with it. So there's lots of moments during its fights where the robot looks kind of sluggish or stuck, and it's like, well, the tail isn't all the way there yet. Or if I'm throwing the other machines around and I haven't reset it properly, it's already at the bottom of its stroke. So now it's just doing this, which is very useful as opposed to like a that, where it sort of throws itself up.
Right.
So it creates a lot of small difficulties in the implementation of it, where it looks less effective than it actually is. Because on good throws, it goes like a foot in the air easily. But when it doesn't, it's like, it just sort of goes poop and doesn't do much. So it's a lot of a dance with the controlling of it.
Interesting. All right, well, good luck with the rest of the competition today. And I'll be looking out for Caddy Wampus to see how it goes.
Excellent. Thank you very much.
Yeah, good to meet you. All right, I'm here with Chase to talk about his robot, Foo Fighter. I guess, what's your team name?
Team 51.
Team 51. All right, so I saw this in a couple matches so far. It's a pretty interesting bot. It kind of spins up. I don't know if it's got melty brain or not, but it bounces around and it ends up just slamming into its opponents. So can you tell me what was kind of the inspiration or thought behind the bot? What did you want to do with it?
I've always had a fascination with like melty brain technology and stuff. Yep. So I figured if I could create like a thwack bot that could turn at high speeds, because I don't exactly know how to do melty brain yet. I'm not really into the Arduino stuff, so I figured if I could put 2 weapon motors, like use a fast rate of speed to turn, I would be able to, create a very high-powered kinetic energy machine.
Okay, I see it. So the motors are kind of like a high-speed, low-torque. Yeah. Are they? They're brushless, I'm assuming.
Yes.
Without like any sort of gearboxing or ratio. So you get a really high speed because it does spin quite a bit, and it just bounces off. Huh? So what kind of challenges did you run into trying to build a bot that would work the way you wanted?
So sometimes, I can't really go into depth about the internals of it, but the wheels sometimes pop off, so we did have to devise a solution for that. Yeah. That is one of our biggest problems, as we are a spinning bot, and we did need to we need both wheels to really effectively attack our characters.
I'm guessing that the wheels didn't come off because of the opponent, but just the centrifugal forces wanted to pull the wheels off.
Another problem we encountered was like the structural integrity of the chassis. So sometimes it breaks on impact with the wall, sometimes it breaks on impact with other bots, so you really have to dial that in.
Interesting. It looks like it's a TPU body. Is that mostly it? The design and shape of the body is kind of key, I guess?
Yeah. It's kind of like a rubber mallet hitting you at a very, very high speed.
Yeah, I mean, what is the game plan of the bot? Is it to destroy the opponent by slamming into it, by putting it in the pit? What do you think? How does it usually tend to win?
Kind of a mixture of everything. I mean, there's really no one way that Foo Fighter wins. It's mainly to entertain the crowd, though. So as long as the crowd's entertained, we're good.
I think that it does. Yeah. I guess I forgot what I was going to say. I had another good question. I just forgot it. Okay. So, how do you go about testing this at home? It seems like it needs a pretty large space to compete in. I'd imagine you need a large space to test it.
So we have a tiny box at home that we set up that's like plywood and polycarbonate. But other than that, we just spin it really low speeds. So we don't usually tend to spin it up to its full potential.
All right, so your big opportunity to really test it out is here in competition.
Exactly. Yeah.
And how's it been going? What's been your, I think you've been in 2 or 3 matches so far, right?
Yes.
What's been your favorite match or event that happened?
My favorite one so far was with Killer Parakeet, where I managed to take a lot of their like wedges and pieces of their chassis off, so that was kind of fun. I like destructive matches.
Right, that's cool. Have you thought about adding anything more hard to the outside to try to impact opponents more?
Yes, but I haven't really gotten to that yet, so hopefully for future competitions.
Okay, so that's in the works, but not you haven't tried it yet.
Yes.
All right, cool. Awesome. Well, Chase, thanks so much for the time.
Nice to meet you. Thank you very much.
All right, I'm here with Roma, who has a very interesting bot. Maybe you could tell me the name of the bot and what kind of inspired you to make it.
The robot's name is Suboptimal. I just wanted a long robot.
A long robot? So it's got like a very, very wide stance for a 3-pounder. I guess is the intent to kind of box in your opponent, or what do you intend to do with that length?
It was originally meant to be a control bot to kind of just corral them, but I was severely underweight, so I added a vertical spinner to it.
Oh, okay.
Yeah.
So that's just a little icing on the top.
Yeah.
Can you tell me a little bit about the weapon system? So, like, what battery? How many cells are you running? Is it a 3S, 4S?
I'm running a 4S and 70-amp weapon receiver with the Just Cuz hub motor.
Okay, interesting. And then for the motors, what are the drive motors? They're
Geckos. Just Cuz Geckos.
Okay, all right, cool. And yeah, it's interesting. You don't even have anything on the top of the bot. The motors are totally exposed, at least from the top. Any concerns with that? Have you run across any bots that have a potential to maybe get at those things?
I've not yet, but if there's a hammer saw, that's the main concern. But
Okay. So what has been like the most difficult part of this bot design at this point? Like,
honestly, getting it up to weight. I've been struggling trying to, like, a few days ago, it's like still half a pound underweight, even after adding a vertical spinner to it. So
I mean, I think a lot of builders would love to have that problem.
Yeah. It's a very nice problem to have.
I noticed on the back you've got some rods rather than armor. Well, what's the thinking behind that?
It was very flexible before because it's all TPU. So I added, they're actually arrows because my family does archery. So we just cut up some old arrows and use them as bracing. Okay. It keeps the bot a lot more rigid.
Interesting. Okay. So that stiffened up the whole bot. I didn't realize that the entire body of the bot is TPU. So the light is TPU as well, huh?
Yeah.
Interesting. And how long have you had this bot? Is this a new bot? Or,
it's brand new.
Brand new. So first fighting here at the Robot Ruckus. Okay. I saw your first fight. I think that was your first fight. Was it your first fight? Okay, all right. So what are your hopes for the day? What was the best matchup, do you think, for this bot versus, what would you like to see as a matchup?
Honestly, I think I could do well against a Peter Bar kit.
Say again?
Peter Bar kits.
Okay.
That's my main thing.
Okay.
But
Interesting. All right, very cool. So I guess is that your only 3-pounder in the event?
yeah.
How about what do you usually do as you prep for a fight? Like, are there any rituals that you do as a lead up to the competition? Anything you're always keen on checking?
I just listen to music. That's
just going out. And just look at the bot and make sure everything's good.
Yeah.
That bot may be bigger than a number of test boxes that we have. So you usually have to test in the big box.
Yeah, for testing, yeah. I have a big test box at home, so it can fully fit in mine.
Cool. Well, very interesting bot, Roma. Thank you for taking the time to talk to me.
Listen to me.
All right, I'm here with Matt Burke, captain of Kraken, and he's got a most interesting bot here, Tentacle Kill, and I was hoping he could tell us a little bit about it. So, go ahead, tell us a little bit about it.
Yeah, sure. So Tentacle Kill is a 3-pound robot. It's all made of 3D printed TPU. Kind of the unique element of it is it uses pinch drive, friction drive. So the 2 weapon motors actually pinch on the weapon, and as they counter rotate like a baseball pitching machine, that's what drives the weapon.
Interesting. So it doesn't have a weapon tied to it, no belt, nothing. It's just a dead shaft.
Dead shaft.
And you are turning the weapon itself with the motors.
With the motors, yeah. So the reason was, since it's a full TPU printed frame, we were worried that as the frame flexed from the gyro forces, it would cut its own belt. And I was trying to come up with a solution that would prevent cutting the belt.
Right.
And I said, well, why don't I just mount the motors at the back and pinch the motor, the weapon shaft, or the weapon, and that way it's kind of held in position. And so far, when it's set up properly, it works okay, and it gets up to speed pretty quick.
Interesting. And how do you maintain the pressure on the weapon?
So the cool thing, so this was not intentional, but it was kind of the unintended awesomeness of it was, as I tighten the weapon shaft down, it flexes the TPU frame and pulls it in, right? Yeah. So it wasn't, I didn't find it on purpose. I didn't know it was going to do that, but I shoved a spacer between here to space the tentacles out, and it pushed the motors away, and so then it wasn't making contact. And then I was like, well, if I would have happened to go the other way, so I just squeezed them together, and it pinched perfectly, and so it worked great. It was kind of an unintended design.
That's pretty cool.
Yeah.
And so those are just standard brushless motors in there.
Yeah, these are just Amazon $5 drone motors I just shoved in there. Yeah, and, nothing fancy about
the 3S system. How do you make sure each motor is turning the opposite way and at the same time? Was that tricky to do, or?
So getting them to counter rotating was challenging, but with brushless you just swap any 2 motors and you get it spinning the right way. And I don't know that they're spinning the exact same speed. There's probably a little bit of scuffing going on, but there's this friction in here, so you can stop a wheel and slide it. It's just hard, right? Okay. So they can slip past each other.
A little bit off.
Yeah, and you'll see after a match, like you can see there's a lot of tire wear there, right? So there's some scuffing going on. We got one motor got hit, but because it was still pinched, the other motor was able to keep the weapon spinning. So even though it was only touching on, one wheel was spinning, it was still working. Didn't have the same power that it did before, but it was still making the weapon go in circles. So,
so what's next for this design? Are you going to iterate on it? What do you want to do based off the experience from this event?
Yeah, so this was our first time competing with this one. We were trying to just, and a lot of the 3-pounders are really purpose-built killing machines. They're just so effective and such incredible pieces of engineering. Yeah, they're fine-tuned machines. So this one was like, let's take something that's extremely functional and do the opposite of that, right? So tried to make it as artistic as possible, tried to make it look like tentacles and stuff like that.
I don't know about that, because you've got this really cool feature of these tentacles wrapped around the weapon axle. Did you do that in CAD? Did you freehand that? How'd you do that?
This was all done with SolidWorks using lofts. This was lofts and fillets.
That must have taken forever.
It was not fast. It was not a fast process. It was several weeks.
Beautiful result, and I love the fact that it's kind of metallic-y TPU.
Yeah.
So it really has that kind of slimy look. I don't know if that's intentional, but you really captured a tentacle feel.
I saw the red TPU on Amazon. It's Overture TPU, high speed, and they had a translucent red, and red's my favorite color, so I thought, hey, that might look cool, and it just worked out. I'm really happy with how it turned out.
That's wonderful. All right, well, I hope I get to see the next iteration sometime soon.
Yeah, absolutely. Yeah, we got to make it a little bit more competitive. We'll just bump it back just a little bit.
Tweak. Yeah,
a little
okay,
tweak.
Okay, cool.
Awesome. Thanks, David. Appreciate it, brother.
Yeah.